So exponentials. We have one more day on exponentials. This is on kind of new stuff. And we don't, we cannot do these without really complicated formulas, the new ones for today. But I want to start with one you could do without a really complicated formula. Do you remember the exponentials where you have a starting number here, and then a 1 plus a rate here, and then this is time? Remember those? Okay, let's put all the info in the right spot. This is the kind where you're supposed to know this formula. We're not giving you this formula. Just like the ACT, they don't give you formulas, except really complicated ones. So on the ACT, they expect you to know simple formulas, but they'll every now and then come along with, here's this crazy looking formula, see if you can use it to figure out the answer. And they'll give you this crazy looking formula. But this one, you'd have to know all by yourself. The ACT wouldn't give it to you. I wrote it on the board, which obviously helps a little bit, but. All right, 500 to start, 1 plus the rate. Wait a minute, they never told me the rate, so what do I put for that? R for the rate. Okay, and then the time, which was 8 years. There. And then did they tell me how much I got at the end? All right. Oh, doubling. So they did tell me the amount of money at the end. By saying it was going to double, it was kind of obscure, but they told me that the amount I have at the end is 1,000. You get what I'm saying? Why do I know that was the case? Because if I had two variables, both y and r, I can't solve. If you have two variables, you'd have to have two separate equations. I don't. I only have one equation. So there can only be one variable. All right, so I knew the y must be given somehow. And when they said it was doubling, it's like, that's how they're giving me the other number. Okay, cool. Would you take that? And by now, I hope I've taught you enough that you look to see if there's anything you could add or subtract at first, and there isn't. What's the next step? You look for things you could multiply or divide, and you can. And then how do you get rid of powers like this? With fraction powers. And I don't want to tell you anymore. I hope you can get this one. I'm going to pause for a second while we finish this off. Use your calculators for sure. All right, so I want you to try one more question here. This one's how much did the rate go up from 2017 to 2018 if gas price was at $2.50 and it went up to $3.50? I think I may have missed over part of the video here, so I'm going to go back and just show this one for those that may have missed it. You guys can work on another question, but this is how we solved our money tree question, and we came out with 9% was the rate. All right, so back here. If we're going to put this in the formula, it's y equals the starting number. Well, which one did it start at? Well, the one that was earlier in time, the original number, 250. And then it went up by some rate I don't know. For how long? How long did I say? 1 year. So put a 1 year. And then what's y? If I had it this way, I couldn't solve it. There's two variables, so I need to know one of them. Must be y. I know the y is the resulting number, which was 350. Is there a shorter way to do this? Absolutely. But in the context of this question, this is the easiest way. The reason this could have been done so easily is because the year was only 1 year. I could have just taken the original, or the change, which was $1, divided by the original number, and it would have figured out that answer for me. That's the fast way. But this little formula way will always work. So I'm dividing by 250, and the reason it's better to know this way is because this way will work even when it's some weird amount of time. You can figure out what the answer is. All right, that one with a calculator comes out to 1 point something. Help me out. 1 point what? 1.4 equals 1 plus r. So I can do this subtraction in my head. 0.4 is the rate. Oh, so sad when I have to have kids go, it's 4%. They get so used to that rates are always like a single digit. This one actually was what? 40%. Okay. All right. Now, what's the new stuff for today about, Mr. Server? We've already done all that before. Because the new stuff for today has to do with let's see here. Sometimes we will give you a strange formula, and you will have to use that strange formula. This is a lot like the ACT, where here's this formula. I've never seen that before. It's kind of related to stuff you've seen before, but you've never seen that exact formula before. try to figure out from the context of the question what goes where and figure out the answer. I don't want to help you anymore because this is typically what happened on the ACT. Here's a formula with some information about the formula. Answer this question. Usually it just means stick a number in the right spot until you only have one variable and then solve. All right, I'm going to pause while you give this one a shot. Act like this is the ACT, and you getting into the college of your dreams depends on this. Okay, let's see if you stuck the numbers in the right spot at least. If the height of the tree is 12, oh man, that's tough. Which one is height? H. Sometimes they have more obscure variables though, like Q, and you got to figure out, well, which one was the height. All right. And then, well, there's only one thing left. It's D, so I just got to solve. So I have tried to teach you to clear fractions. So I would recommend that you have times this by 3 on both sides. That gets rid of the denominator. Did I not teach you to clear fractions? All right. Now, could you have, in this case, multiplied by the reciprocal? Yes, but I don't recommend it because in a harder problem, it screws it up. So then it's 36 equals 5D to the 0.8. Now I got to get rid of the 5. Divide by 5. Divide by 5. That cancels. And now I can put it to the 0.8 power. No, I just got it wrong. How do you do the reciprocal of 0.8? You can do 1 over 0.8, but there's a sneakier way. What is the right way to say 0.8 officially? 8/10 or 4/5. And so if this is 8/10, then you could put everything to the 10/8 power. Also known as 10/8 would be the same as 5/4 power. That would have worked. All right. So final answer. Find the diameter. D equals 36/5 to the 10/8, also known as 5/4, or also known as 1.2 power. What did you get? I'll ask a random person. Dice of Destiny. You should ask row 5. First person, that's you. 11.7. Which way would you round it? 11.8?
Yeah.
Okay. Raise your hand if you would have rounded yours to 11.8. Awesome. Okay. Now, there is a couple formulas you're going to use a lot and that you already know. And then there's 2 new formulas for today. One of which you have to memorize, and one of which you have to not memorize but know how to use. Okay? This one has the whole quarterly thing in there. We haven't done that for a while. All right, so there's a special formula that we use for that kind. And this is not it. Where is that big old beast of a formula? It's not listed in here. It's in our homework. Okay. Fine, I'll do it from memory. So I do have it memorized. So would you agree that in the old days, like 2 minutes ago, you would have started with 4,000 and then times by 1 plus a rate and then to the time? Does that ring a bell? That's what we just did like a minute ago. Okay. So how should it be different if it's quarterly? Divided by 4. But that's a big deal because now all of a sudden our time was in years. How are we going to make our time not be in years anymore? Really close. Times it by 4. I want you to think about what that means. If I had 1 year, do you get that's 4 quarters? And so I want it to be time 1 year times 4 would mean 4 quarters of growth. All right, so it is the most common mistake is people think you divide up here. I even did it in my first hour. You don't. Because if I put in 2 years, do you get we want to have 8 quarters? So that'll do 2 times 4 will give us 8 quarters of growth. 2 years would be 8 quarters, right? So anyway, you divide this one by 4, but you times that one by 4. Okay, so now let's actually finish off. We know some more that we haven't put in here yet. 3% interest, that's the R. So I'm going to put in 0.03 right here. Hard to read that. I'm going to change it to black. 0.03 right there. And then our time, they didn't tell us the time. Oh, here it is. How much money will he have in 3 years? There we go. Now I can put the 3 in. And you get, if I hadn't times it by 4, the computer would think I was saying 3/4 because I had divided by 4 before. So I got to go 3 times 4 up there. The final answer is 4,000 times 1 plus 0.03 divided by 4 to the 3 times 4. You could have just put a 12 there, but I'm showing my work. That one is complicated enough that we are going to let you have that one on the test. We will tell you that formula. You know why? Because everybody, not everybody, a lot of people will divide up here by accident like I did or in first hour. Okay, so we're going to give you that formula for the test. The formula we're not going to give you is this last one. And it's really got a snappy name, pert. This one is one you'll have to memorize. This one is based on E. And you have to understand that E is not a variable. E is like pi. E could be a variable, but we mathematicians have decided that E is just going to always be a certain number. Kind of like we decided on pi. Pi was always going to be 3.14. Like you have never seen a variable called pi. Solve for pi, kids. You don't do that because pi is supposed to be 3.14. Same thing with E. E is supposed to be 2.718. I know you don't know that already, but now you do, and now you need to know it. And it says so right here. If you look on your calculator has an E button on it. Let me show you where it is. See the divide key on your calculator? See right above the divide key on your calculator? Go ahead, hit that. Make E come up on your calculator. Hit enter. Do you get that since you have a calculator for this next test, I do not need you to memorize it right now? But wouldn't it be a decent idea to kind of like know kind of about what it is, like about 2.7? Sort of like, what you need a calculator?
No, get a calculator.
You are allowed to use a calculator on your next test, yes. Okay, so on this part of the test, you need to know the formula, but your calculator will know what E is for you. You won't have to memorize E. But it's 2.718. If you want to memorize a number that's kind of handy like pi, 3.14, that was really handy, like through a lot of high school and middle school at least. Well, this one will be handy for high-level math because E comes up over and over and over again. This is your first intro to E, but E comes up in pre-calc and then again in calculus. So in a minute, I'm going to show you a little bit more where E came from, but let's just see how easy this thing is to use. So if I have this formula memorized, PERT, P stands for principal. Remember the principal is your starting amount? And remember how after the equal sign, we always put the starting amount there? That's not too hard. E is a number. I just told you, it's 2.718. R stands for rate, and what do you think T stands for? Time. Okay, so this one's a really simple formula to know and use. If you can just memorize PERT, P, E to the RT. This is times, in case that isn't clear, and the RT is an exponent. It is an exponent, in case that's not clear. So if you were going to use this to solve a problem, typical question looks like this. And here's the key that you look for. Continuous growth. Because that's what E is good for. You've heard of compounding quarterly, just 4 times a year. You've heard of compounding monthly, which is 12 times a year. But if you want to compound yearly, 365, the craziest kind of compounding is all the time. Continuous compounding. Not even every second. It's more often than every second. Continuous compounding. It's a weird concept. So like if we had 10%, or no, 12% interest, to keep it really simple. 12% interest, it's sort of like dividing it up monthly would be about 1% a month. You know what I mean? Daily, you could figure out some small amount that you get per day. It's not like it's all of a sudden turns into 12% a day. It's just being recompounded. Figure out how much do you owe now. And if you recompound it, the more times you compound it, the more money the person gets, because the more compoundings, your 10% interest compounded only once at the end of the year is simple 10%. But if it's an annual percentage rate and they get to compound it continuously, you pay a little more than 10%, because they get to give you your interest bill like every day, and it kind of compounds on itself. There's a little bit of compounding growth in there. Okay, so the moral of the story is you should be able to look at this and go, oh, it said continuously, that's pert. Okay, and it's P times E to the RT. All right, what is the principal amount? Well, that's the starting amount. Did it tell me how much I had at the beginning? Yes, the initial population was 250. 250 times E. Remember, you can just put E, just like you write pi normally, right? Could you replace it with 2.718? Yes. The calculator would be even more accurate if you use the calculator's button. And then R is the rate. Oh, it tells me the rate. Hint, you got to change this to 0.046. You cannot use 4.6. The answer would be way too big. And now it's, okay, 4.6 per day. Oh, per day. And then it says after 36 hours. Ooh, sneaky. So you better not use 36. That would be 36 days, right? What should we use for time? Think it through. 36 hours is 1.5 days. Does that make sense? This rate was per day, and so I got to use days here. And they gave me 36 hours, curveball, so I used 36 divided by 24. That's 1.5 days. All right, so it uses a fairly innocent formula, pert, but it threw in a wicked little curveball. I could see a kid easily thinking, oh, I'm just going to put time is 36. It says time is 36, but that would have been in hours, not days. And this rate was in days. You want to keep the units the same. And anytime you have units working together, they got to be the same. It is hard enough that NASA even messed it up. Did I tell you about the units thing on the Mars lander? Okay. Some of you may not have heard it, but when they launched the satellite supposed to be currently revolving around or orbiting Mars, it crashed when it got there because somebody screwed up the conversion between meters and feet. And that's all it takes. Oops. $1 billion satellite went up in flames. So a little rover that's sitting on the surface, way overachieved though. Did I tell you that part? Okay. Anyway, it's been working for 5,000 days and it was only supposed to work for 90 days. That's pretty awesome. So it's still driving around up there, still sending back data. Still hoping that some Martian's going to like pick it up and go, what's this thing? But it's because the Martians have been refueling it. Maybe they use their cloaking shields when they walk up to it so nobody can tell. Oh boy, here we go. Okay, so let's go to a scan of your gallbladder. Ooh. So it involves an injection. Oh man, my daughter would have been out on the floor by now, so I don't want anybody to pass out. I'm going to move on to a different problem. All right, let's actually start your homework together. It's a worksheet, and it looks like this. I wonder if it's... I'm going to pause for a second. Okay, so here we are on this right worksheet. Let's start it together. It's got y equals... I'm not going to write the whole formula out by now. I hope you know it. After the equals is what you start with. Which of these two is what it started with? The 425. And then it's times by 1 plus the rate. And then it's over 5 years, so that's 5. Did they say it was quarterly or monthly or any of that kind of baloney? No. So then I don't have to worry about that. If it had been quarterly, remember I would have gone divided by 4 and times 4. but this was not quarterly, so I'm going to take those out. All right, now I have ending amount goes here, 550. Now, I hope you can solve for R from there. Hopefully that's easy street. All right. When you get to number 4 on the worksheet, this is kind of like one of those ones I told you about where on the ACT, they're going to give you a complicated looking equation that you never heard of before. And you got to figure out where to stick the right number and then solve it. So since they said whale, I'm guessing that's W, but I'd probably look just to make sure, oh, it's actually weight is W, okay? So, oh, that could have been bad. So it could maybe have stuck that number in the wrong spot. It tells you in the directions what's what. The length is L, well, that makes sense. All right, so they want me to solve for W, and it's 62 feet long, so I'm going to stick that in for L. So if I stick the 62 in right there, it'll be easy to solve. Basically, the moral of the story is, don't expect you'll know every formula. They'll give you a crazy formula. You got to read it, figure out where to put in the info, and solve. And since we're in a unit called exponentials, a lot of times you're going to have fraction exponents. All right, I'm going to tell you which ones I want you to do and which ones you can skip. I need you to do 1, 2, 3, and 4, the first 4 questions here. And then we are going to skip a fair number of them, so pay attention. All right, you may skip number 5 and all of its parts. I think you should do number 6 because it is got the main formula that I told you that we would not make you memorize. We should do that one. We're going to skip 7 lucky 7. And then we're going to do number 8 because it's the other main formula. And I said this was pert was easy enough. We would expect you to have it memorized. Pert, so do 8, including part A and B. Number 9, you may skip all its parts. Number 10, since it's about Ewoks, we need to do it. Number 10. Then we get to a big old review section. I'm going to tell you certain ones that I want you to do and skip here too. I'm going to have you do A, C, and E. They're going to call it the ACE questions. Do A and C and E in the next section also. A, C, and E. The ACE problems. Down here in number 18, number 13, sorry, number 13, just A. I think we've practiced these enough that I don't think you need more practice, but hey, if you really are bad at A, you better maybe practice a little more because there's a bunch, and I'm only requiring you to do A. Again, if you can't handle this kind, please do a whole bunch. If you can get A and you got no problems, then we're good. Same with number 14. There's 4 graphing ones. I'm saying you can just do one of the 4. It's cutting it down a lot. For some of you, maybe that's cutting it down too much. If you're terrible at graphing, you should probably do more. How many points do I want? 3. And the what? And the asymptote. 3 points in the asymptote. And again, if you need it, do more than that. Okay, that's all I have for you for today.